Hello everyone, this is Unit 1, Lesson 6. The learning target is I can find missing angle measurements when parallel lines are cut by a transversal by creating equations using expressions. So the do now says find the measure of angle 6. The measure of angle 3 though they give you as 46 degrees. So we're going to put that in. Anytime they give you an angle measure, you just want to put that in as far as like where it is, because a lot of people are like me, visual learners, and when something is over here in print, it's not as effective as being over here actually in the diagram. So right now, just put 46 degrees right into the diagram. It says find the measure of angle 6. So what I'm going to do is I'm going to draw a dotted line to angle 6. So if this is 46 degrees and this is an acute small angle, what do you think this will be? It's the same acute small angle. So if you did say 46 degrees, you are correct. What is the relationship between 6 and 3? Are they corresponding, vertical, alternate exterior, or alternate interior? So go ahead and think about that, answer the question, and then we'll go over it. So the relationship between 6 and 3, these are the parallel lines right here. Inside the parallel lines is called interior and across from. So alternate interior angles, angle 6 and 3. Alternate exterior would be a pair like 1 and 8 or 2 and 7. Alternate exterior means outside and across. All right, so that's outside and across. Corresponding is probably the most difficult one to remember, but corresponding means that it is basically in the same location. All right, so if you look at the 4 angles up here and then the 4 angles down here and split them, like in your head, you split them in two, an upper half and then a lower half, you would say that one is in the upper left, or in this case, the upper part of this diagram that is on the bottom. The upper part on the bottom, and 5 matches in that same location in the upper part of the bottom half. All right, upper left, and that's the way you kind of take a look at it. Look, 4 is in the lower right hand side of the top part. Which angle is in the lower right hand side in the bottom? Well, it's 8. So that is corresponding. Same location. All right, corresponding angles, corresponding sides. Vertical angles are just across from. They're across from each other, so 1 and 4, 2 and 3, 5 and 8, and 6 and 7. And that is basically it. So in this Explorer, it says identify each of the missing angles. And we're going to talk about, all right, this one is a tricky question. It says the sum of 2 and 3, of angle 2 and angle 3, is 136 degrees. So 2 and 3 are right here, and I'm going to circle them. And it doesn't say that each of them measure 136 degrees. It says that the sum of them, when you add them together, equals 136 degrees. So I'm going to put right in between them 136 degrees. So it's this one plus this one. So the question is asking you, find the measure of angle 1. So it's this one. So let's go ahead and find that measure. So you have 136 degrees. We don't know individually what 3 and 2 are. Let's see. Here is a triangle. So there's the triangle right there. What we want to do is find the measure of angle 1. And you know all of the interior angles of a triangle equal 180 degrees. So if these two, when you add them together, equal 136, what would you have to do to find the missing angle measure that would eventually have to be added to 136 to get 180? So hopefully you did say 180 minus 136. And no matter how easy the problem is, always go ahead and put in and use your calculator. Put the numbers in your calculator. Use it. 136, that's 44 degrees. So angle 1 is 44. And I'm going to put that directly in to my diagram, because looking at it now I see exactly what it is, all right, in the diagram, and I don't have to shift eyes back and forth. So now they want me to go to see what the measure of angle 4 is and the measure of angle 5. Well, right now I feel like the measure of angle 5, and I'm going to get my highlighter out and possibly do a different color. What is this? What is this? If I go back and forth with this right here, what does that create? 1 and 5. If you said a straight line, you are correct. And now this is the next question. At a straight line, how many degrees makes up a straight line? And a straight line is half a circle. So if you said 180 degrees, you are correct. All right, so 180 degrees makes up that straight line, and this is what I'm talking about here with 1 and 5. This is 5, and this part right here is 1. So this angle right here is 44 degrees. How do I get the measure of angle 5 if the whole thing measures 180? Well, if you said 180 minus what you have is 44, and then you take your calculator and do that again, 180 minus 44, always have your calculator by your side, it's really important. It's 136 degrees, so I'm going to write that down as 136 degrees. And then at this point, I'm going to put 136 degrees right here. Okay, so now all I need, and actually that is wrong, so we're going to change that. That was the measure of angle 5. I went to the angle 5 first, so I'll change that right now. And I did. So that's the measure of angle 5, 136 degrees. That's why it's so important to put the angle measure into the diagram, because I realized that I would have the wrong answer for measure of angle 4. Because measure of angle 4, I could tell right away, is not going to be 136 degrees. It is a smaller acute angle, and this is the angle right here that we're talking about. This is angle 4. All right, angle 5, Think about how that's obtuse. It's a large angle. It's greater than 90. So 136 degrees. So how can I get the measure of angle 4? So I'm going to do something, and I'm going to extend this out a little bit. Take a look. What are these right here? If you said parallel lines, you're correct. I'm going to extend this out. That's exactly the figure that they always give. They give these parallel lines and then cut by a transversal right down that middle part right there. So if this is 44 degrees, what's this? Right across from it, across the transversal, inside the parallel lines. So if you said alternate interior angles, you are correct. All right, and alternate interior angles are congruent. So that means angle 4 has to be 44 degrees. Angle 1 and angle 4 are alternate interior angles, so they are congruent. And remember, like in parallel lines, these are vertical angles here. If you needed to get it, this would be a vertical angle. This would be 44 degrees. All right, and then this would be 44 degrees. You do that kind of like crisscross right there. So angle 4 is 44 degrees. And that's how you would do that problem. Hopefully you did understand it and were able to follow through. So we have more questions. So what's the relationship between angle 1 and 5? So if you are, we're going to worry about the fast finisher later, but go ahead and try B and C on your own before I put the answers down. You could press pause now. So hopefully you did try those and you did get the answer. But what is the relationship between 1 and 5? So I'm going to put my pen right on 1 and 5, right here to here, 1 and 5. What's the relationship between them? They're equal to 180 degrees. So they're supplementary. And supplementary angles equal 180 degrees. What's the relationship between angle 1, 2, and 3? And for that, you should have interior angles of a triangle. And also, they are supplementary. Even though there's 3 of them, supplementary angles because they're equal to 180 degrees. And that's basically it. So this is labeled as a fast finisher, but the thing is, we want you to try these. Don't skip them. And believe me, these aren't that difficult. The first thing I do when I look at something like this and there's a whole bunch of angles missing, I start filling in what I know. And I know straight lines are 180 degrees. I know triangles are 180 degrees. I also know that vertical angles are equal to each other. So if I could just fill in some vertical angles, then maybe I could, get something going here. So we're going to try to just fill in all of those missing angles. So the first thing that I'm looking at right now, and it might be something that you've seen, that you did see, because it's just straight right in front of me. This right here, that's a straight line. So if that's a straight line, that means I know it equals 180 degrees. So if it equals 180 degrees, I'm going to go over here. I'll put it over here. I'll do 180 minus 68. Because I know that this measure of angle M has to be, and this angle right here, when you add them together, equal 180. So I am going to take my calculator and do 180 minus 68. And that is 112. So that is my first angle right there that I know this is 112 degrees. Okay, so now I'm going to look and I'm going to just highlight something that maybe you did see. If I have two angles of a triangle, it's easy to find the third. But if I only have one, it's a little bit more difficult. But see this right here? I'm going to highlight this, this, and this. All three sides form a triangle. You could see it right now. So I'm going to take this and this. Since they give you two of them, I'm going to take them and I am going to add them up together. So let's go ahead and do that. We have 73 plus 83. And I'm going to get my calculator out. I'm not going to leave anything to chance. 73 plus 83. Enter 156. So if that's 156, I'm going to put that in right now as 156, this angle. 156. Not bad. Now, I'm going to highlight something else. I'm going to turn it to yellow. All right. So I ditched the highlighter and I did just do that in red. There's another triangle. And look, you have two angles of a triangle and you're looking for Z. So the next thing I'm going to do is 156 plus, and that is 112. No, it's not. I'm so glad I made this error. So look, just take a look. I'm thinking, wait a minute. 156 plus 112, that's way over 180. So how could, I'm going to highlight it again. I'm going to just go like this. 156, 112, and then I stop. I know it's over 180, so something has to be wrong. It's this. I didn't even realize it when I put it in. This can't be 156. Let's try it again. I have 73 plus 83, 156, and I didn't do anything else. What else do you have to do to get the missing angle? Yeah, you have to take 180 minus 156. So you see, these things that I'm doing incorrectly, that's exactly what a lot of people do incorrectly. Your angles, sorry, I put that in the wrong. So your angles are supposed to add up to be 180 degrees. So if it doesn't add up to be 180 degrees, just like I did, you have to stop. So that's 24 degrees. Then you take 112 and add 24. You get 136. You do 180 minus 136. And that's 44 degrees. Now, if you add all of these up, it should be equal to 180, and it is. Right? So the only thing that we have to get now, see this U? They don't want that. That's just the point. That's that point in the middle. They want this though, the degrees. Find all the missing angles. So I'm going to change it again to blue, and we have a triangle right here. Do you see your triangle? Is another large triangle. Here's one angle of the triangle. We need another. We do have it. So we have 44 plus 64. All right. And 44 plus 64 is 108. Then 180 minus 108, which is always that last step. 180 minus 108 is 72. And 72 degrees is y. So you see the mistakes that I made going through. And actually I caught the mistake because, again, I was trying to add 156 plus 112. You see this? 156 plus 112 is way over 180. And I want you to stop like I did and realize, hey, wait a minute. Triangle could only be 180 degrees. I must have done something wrong. So when you also put, and I didn't even realize, 156 can't go for an acute, it can't go in the place of an acute angle. It's not 156 degrees. All right, so those things, that's why we wanted to go over this fast finisher. Another thing, if you really wanted to, if they wanted you to, you see this straight line? This angle here, how would you get it? How would you get that missing angle right there? So if you said 180 minus 73, you are correct. And again, 180 minus 73, easy enough to figure out, that is 107. If you wanted to solve it, you could. All right, straight lines equal 180 degrees. And if they wanted you to solve this, these are vertical. Vertical angles are equal to each other. And remember, vertical angles are equal to each other. So this is 68. So you could really solve, they could have asked you a lot more than they did. They didn't, but we finished the problem and you get, hopefully you had the hang of that. All right, so let's go on to this question. In yellow, we have the choices that you're going to put here, 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 and answer all the questions down to D. You're going to answer all these questions down to D based on this figure right here. Go ahead, answer all the questions, press pause, and when you're finished, you can press play. But press pause and give the questions a try now. So this is, hopefully you did give them a try, and now we're going to check your answers. So what is the relationship between 1 and 4? So I'm going to circle 1 and 4 across from each other, right across from each other. So are they alternate interior, alternate exterior, corresponding, or vertical? Yes, if you said vertical, you are correct. Vertical angles right across from each other. Can't be alternate interior because both of those angles are not interior, and it can't be alternate exterior because both of those are not exterior. 1 is exterior, 4 is interior. Can't be corresponding because corresponding is not in the same, these are not in the same location. What's the relationship between 3 and 6? Now we're going to just take these right here, move them out, and move them down. So 3 and 6, right across from each other, but both on the inside. So you should have had down alternate not exterior, interior, because both of these angles are inside the parallel lines. What is the relationship between 1 and 8? So 1 and 8, I'm going to erase these, and I'm going to just put a circle around 1 and 8. Still across from each other, but now on the outside they're both on the outside of the parallel lines. And if you said alternate exterior, you're correct. And the last question, what is the relationship between 4 and 8? So I'm going to erase those again. 4 and 8. 4 and 8. 4 is in the lower right-hand location of the top, and 8 is in the lower right-hand location of the bottom. Same location, same spot, so that is corresponding. Those are corresponding. All right, the relationship between 4 and 8 corresponding angles. And that is it. So we're going to move into a part of the lesson that might be a little bit difficult for you. But if you pay attention to what I'm doing, I'll do the first, the first couple with you, and we'll explore together, and we can hopefully make some sense of it. So question A asks, are the angles with the expressions labeled 5x plus 2 and 3x plus 10 congruent or supplementary? So let's go over some vocabulary, and let's just go over what we have up here. So we are given an expression. An expression is 5x, like a 5x plus 2, no equal sign, an expression. Then also we're given another expression here. What we usually have are numbers given. So we would be told that one of those angles is equal to like 25 degrees or 30 degrees. And then we would just say, all right, if this is 30, then this has to be 30, right? Because they're vertical angles. So are these angles right here and right here, are they congruent or are they supplementary? Congruent means equal to. Supplementary means you could add them up and they would be equal to 180. So are these angles congruent, equal to each other, or are they not equal to each other? Are they equal to 180 if you add them up? So if you said congruent, you are correct. So are the angles congruent? Yes, they are. And why are they congruent? They're equal to each other. They're vertical angles. They're vertical angles. So please write that down. Now it says set up and solve an equation that would help you solve for the missing angles. So if these are equal to each other, you have to set them equal to each other. Vertical angles are equal. If these angles are vertical, then they're equal. Look, this is an acute angle, and this is an acute angle. Whatever this angle is, the measure, it's going to be the same for this angle, the measure. So if this angle's 30, this angle would be 30. I'm not saying they're 30. I'm saying if this angle was 30, that means you would just fill in the 30 right here. So if they give you 5x plus 2 and 3x plus 10 at vertical angles, the first thing that you do is put an equal sign down. And on the left side, put the 5x plus 2. Doesn't matter which side you put it on, but I'm just saying. 3x plus 10 is on the other side. They're equal to each other because these angles are congruent. They will be equal at the end. All right, so let's go ahead and start solving this. Remember, we have variables on opposite sides. This is why it's so important to make sure that you know how to solve equations. So the first thing that you always do is to get the x's together. And what I'm doing right now is to get those x's together. It's the opposite of 3x, positive 3x, which is negative 3x. 5x minus 3x is 2x. Then you bring down the plus 2 in the equal sign and the 10. And then you just have to solve for x. So you minus 2 on both sides. I'm going to move this down a little bit. Put a big line. This cancels. Minus 2 on both sides. You have 2x equals 8. Divide by 2. Divide by 2. X equals 4. X equals 4. But that doesn't tell me what the angles are. So it says set up and solve an equations that would help you solve for all the missing angles. You actually answered the question. But I want to take it one step further because I want to solve for the missing angles. So let's go ahead and every single time, let's just say this, every single time that you solve for x, if they ask you to solve for that angle, you're going to substitute. You're going to substitute whatever you have here into here, into the expression that they give you. So it's 5 times 4, and every time that you put something in the calculator, or any time that you write something down, use parentheses to show that you're substituting in the place of multiplication, right? So you have 5, and then look, I'm not even going to press the multiplication button. I'm not going to press this. I'm just going to put 5 and 4 in parentheses because the calculator will know that you mean multiplication. So this right here is 22 degrees, and I'm going to put that down as 22 degrees. Now I know, since these are vertical, that this should be 22 as well. But let me just check it out because we're not completely sure. 3, we're not completely sure because we don't know if our work is correct. But if it is, that means it will be equal to 22. So 4 times 3 is 12. So I'm going to do 4 times 3 plus 10. And hopefully that equals 22. It does. So you see that they are equal to each other. How would we get this angle and this angle though? Remember, we have a straight line. Look at the straight line. There's a straight line. Here's a straight line. 22 degrees plus this equals 180. It's half a circle. It's a semicircle. So let's do it. 180 minus 22. It's a straight line. That's why we're doing that. 180 minus 22. 158. This is 158. If this is 158 degrees, what's this? The angle that is directly vertical to 158 degrees? Yep, 158 degrees. And that's it. All right, you solved for all the missing angles, but just remember, the expressions that they give you in the place of what would normally be angle measures, numbers, they're equal because these are vertical angles. And that's the only reason why that they are equal. So I am going to move this over, and we are going to start this problem right here. So I'm just going to take a look at this expression that they give us and this expression. That is along a straight line. The first question that they ask you is, are the angles with the expressions labeled x plus 16 plus 3x congruent or supplementary? If they're congruent, that means you think that in this case they would be vertical angles and that they're equal to each other, that they're exactly the same. If you think they're supplementary, you think they're part of a straight line that equals 180 degrees. Two or more angles that equal 180 degrees, those are supplementary. So take a look at what we have here, x plus 16 and 3x. This is obtuse and this is acute. Small, large. There's no way that you could say that these are congruent, that these are equal to each other. So they must be, if they're part of a straight line, they must be equal to 180 degrees if you add them. And there's no way that you set them equal. All right, so we're going to say that these are supplementary because they equal 180 degrees. So set up and solve an equation. So now that we have this, it's x plus 16. You can't put equals because they're not going to be equal. But if you do add them up, what should they be equal to? Supplementary angles equal 180 degrees. That's how you would set this up. All right. Understand, the only way that you're setting angles equal to each other is if you think that they are the same angle, same measure. All right, they look the same. These do not look the same. One's acute and one's obtuse. No way. All right, so now we have to go ahead and combine like terms because you have x's on one side of the equal sign. Please don't move anything across that equal sign until you combine like terms. So you have x plus 3x is 4x. I'm going to bring down the plus 16, and I'm also going to bring down the equal sign and the 180. Then we are solving an equation minus 16 on both sides. We're going to draw a nice big line. This cancels, and I'm going to go up over, actually I'm just going to move down a little bit. 4x equals, and I'm going to do, just be super safe, 180 minus 16, 164. Then you do the opposite of multiplication, which is division, and you divide by 4 on both sides. You get x equals, and let's see what x equals, 164 divided by 4. And that is 41. None of these angles are equal to 41 degrees. We have to substitute, right? So I am going to substitute here 41 plus 16. And having the calculator right next to you definitely does help. We have 57 degrees. So I'm going to put this as 57. And then I am going to do 3 times 41. And remember, my x is 41. That's what I solved for. So I'm going to go 3 times 41. I didn't press the multiplication symbol. I just put that parentheses 123. So if this is 123, so is this. They're vertical angles. So if this is 57, so is this. They're vertical angles. Just checking 123, this is 123, plus 57 is 180. And you could just do that in your calculator, 123 plus 57, 180. Straight lines equal 180. Every straight line, 123 plus 57, straight line, 180 degrees. 123 plus 57, these are supplementary, 180 degrees. 123 plus 57, 180 degrees. These are vertical, these are congruent across from each other, they're equal to each other. So we're going to move down to this question right here, and we're going to show you, it really looks difficult. There's a lot of angles that are missing, actually 12. They list 12 angles and they only give you 2 of them. but I'm going to just show you how easy this could be, or this actually is. So I'm going to just go ahead and start filling in the easiest thing that I know. And the easiest thing that I know, vertical angles. Vertical angles, so across from each other. 45 degrees, 12 is 45 degrees, vertical. You see these parallel lines? Look at the parallel lines. Alternate interior angles are equal. Here's 45. 3 and 1, and this angle here, 1, 45 degrees. Okay, so now I am going to do 50. I could stay over here, or I could come over here. There's a lot that I could do, but I could just take 55. Let's just talk about what this is here. So I'm going to clear this out. So this is 55. This is a straight line, right? There's your 180 degrees. But before that, this is 55. I could do 55 here because they're vertical. Right? Not bad, right? So here we go. We have 55 plus whatever equals 180. So I'm going to do 180 minus 55 because I know that those angles are supplementary, and I have 125. And I have another vertical angle here. I know this is 125. All I did so far was just 180 minus 55, and look at how many angles I have filled in. Right? Everything's based on a straight line, supplementary angles, and everything's based on congruent angles of vertical. Right? So I know 2 and 4 are vertical angles. I know 10 and 6 are vertical angles, but I'm going to concentrate on 2 and 4 because here's another straight line. You see 180 minus 45. 180 minus 45 is 135 degrees. And since I have 2, I have 4. Not bad, right? Here, look, here's another, this alternate interior angles. Here's a transversal here, parallel lines, alternate interior angles. You see it? I'm going to fill in 55. Now, since I have 55 here, vertical angles, 55, are equal to each other. So now I just need this. If I could get this or this, let's talk about this one, 11. Here's a straight line. Straight lines equal what? 180 degrees. So you would do 55 plus 45. And obviously that is 100. Then you do 180 minus 100, and it's 80 degrees. 80 degrees, vertical angle, 80 degrees. Not that bad. Look how easy that was. Just based on one thing, getting vertical angles and straight lines down pat, recognizing them in a figure like this will definitely help you out big time. All right, so we are going to move to this type of question, and this type of questioning you'll see a number of times in our class and also on the state exams and on any exam. So we are going to circle. It says the first question, are the angles of the expressions labeled 4x minus 20 and 2x plus 10 congruent or supplementary? So every single time you have to decide whether or not you feel these expressions are inside of angles or represent angles that are equal to each other, exactly the same, or are they different? And that means they're supplementary in this case. So let's circle what we have. We have 4x minus 20, and we have 2x plus 10. What I want you to do is take a look at the angles and set up an equation on your own telling me that you know that these are either equal to each other, or when you add them together, they're equal to 180 degrees. All right, so before we press pause, we're going to write down two possible equations. You either think that they're equal to each other, or that you have to add them up and they equal 180. If you think that they're equal to 180, that means they are supplementary angles and that they're different measures. All right, one's acute, one's obtuse, equals 180. If you think that they're equal to each other, that means you think that the angles are exactly the same measure and they look exactly the same. Go ahead, pick an equation and see if you can solve it. All right, are these angles equal to each other, or are they? Actually, we're not going to press pause yet because I want you to solve the right equation. I don't want you to waste time solving the wrong equation if you do pick the wrong one. All right, so are these equal to each other, or are these supplementary? If you said that they're equal to each other, you're correct. So we are going to erase the other one. All right, and we're erasing it because these are not supplementary angles. Look, if you say, all right, this angle here is acute, this angle here is acute, this angle is definitely going to be equal to this angle, that's why I set them equal, then that's good. You realized it. But what is the relationship between these angles? What are they called? What's the relationship between those angles? And if you said corresponding, they are corresponding angles. Corresponding angles are in the same location. And they're equal to each other. They're in the same location. This is in the lower right. This is in the lower right. So setting them equal to each other is correct. Now go ahead and solve, and then substitute to solve the measure of angle 7. Press pause and try the problem now. Okay, so we have 4x minus 20 equals 2x plus 10. You subtract the 2x on both sides. You have to get the x's together first. Remember, the 4x minus 2x is 2x. You bring down the minus 20. You bring down the equal sign. You bring down the 10. You add 20 on both sides. You get 2x equals 30. Divide by 2 using inverse operations all the way through. And then you get x equals 15. X equals 15 is not the answer, though. They want the measure of angle 7. So we're going to circle the measure of angle 7 right here, and we want to find that angle. So this is an obtuse angle, and this is an obtuse angle. These are vertical angles, so that's not going to help us. But this angle right here, this expression, is right next to that 7. So if we find this one, the 2x plus 10, what that is, then we could find what 7 is by doing 180 minus whatever this is. All right, because these are supplementary angles, and you would subtract to get that. So I'm gonna just substitute in here 2 times 15 plus 10. And just like what I did on the calculator, 2 times 15 plus 10. 40 degrees. So if that's 40, I could take, so now I know that this little part is 40 degrees. I know what this is. It's 180 minus 40. And it's 140 degrees. So I'm going to put in 140. And I'll put that in right here. All right, and that's it. But remember, from the start, this is the part that we want you to understand. We want you to understand that, hey, these angles, and notice right away that if I have these angles, they're corresponding angles. If you don't realize that they're corresponding angles, at least realize that they're the same angle, same measure, both acute, both the same angles, equal to each other. All right, and hopefully you are able to get that question correct. All right, so we are into this question. Go ahead, and this is the first thing. Now, before we press pause and try this problem, it's giving you what angle 1 and angle 3 are. What I want you to do is write these expressions inside the figure. So we have 2x plus 10, and I'm going to write it down, 2x plus 10, inside the figure. And then angle 3 is 3x plus 10. So I have both of those angles down, and now I can make a decision. Are these equal to each other, or are they part of a straight line that you would have to add together to make it equal to 180? Go ahead, try to put the equation down. Pick an equation. There's only two. Equal to each other, or part of a straight line. Put that equation down, press pause now, and we'll discuss it when we come back. So if you did say 2x plus 10 plus 3x plus 10 equals 180, that is correct, because these are supplementary angles. So to answer the first question, they are supplementary. And they're supplementary, you could tell right away, because they are different measures. All right, one's acute, one's obtuse. So we set them up like this. Now we have to solve your equation, and remember, you have to solve combining the like terms. So I'm going to box out 2x plus 3x, and hopefully you get 5x. And then 10 plus 10 is 20. Solving is very, very important. So remember, you have an x over here. You have to do the opposite of what positive 20 is, and it's negative 20. I'm going to draw a line like that, and then 5x equals 160. You divide by 5 on both sides. You will get what x is, and just because I want to be safe, 160 divided by 5 is 32. X equals 32 degrees. Or 32, I should say. They want the measure of angle 1. The measure of angle 1 is here. This is the expression. So I'm going to put it right here, 2 times, in parentheses, 32 plus 10. 2 times 32 plus 10. Even if you could do it in your head, get used to using that calculator, get used to using the parentheses to show substitution. 3 times 32 plus 10. Again, I'm going to grab that calculator. 3 times 32 plus 10. 106. Just to check, I have 106 plus 74. 180 degrees. Because they're part of a straight line, they're equal to 180 degrees. They just wanted the measure of angle 1. Angle 1 is 74 degrees, and angle 3 is 106. From there, you could figure out all of the missing angles, vertical and all that, but They didn't ask you to, so you just, you're not going to do that. Going on to the next question, this is a little bit different, but just remember what these are. They're either equal or they're not equal. All right, they're supplementary if they're not equal. So that means you have to set up your equation using these expressions, angle 1 and angle 2. Set up your equation and think about, do you think that these are going to be, are these equal to each other? They're the same angle, or are they different angles? If they're different, you set them up, adding them up and equal to 180. If they're the same, you set them up equal to each other. Try that, write the equation down, solve it, and then substitute in for the measure of angle 1 and angle 2 right now. You can press pause and try it, and then you can press play just to see that you have the right equation, and then press pause again and solve the equation. Press pause now. So remember, you cannot say that these are equal angles. These are not equal angles. They are part of a straight line. This is the straight line that I'm talking about. They are part of that straight line. So if they're part of a straight line, you cannot say that they're equal. So once you have your equation down, and I'm going to go quickly here, I am going to box out my like terms. Hopefully you did this already. So 2x plus x equals 3x, and then 17 minus 5 is 12. All right. Now you subtract by 12 on both sides. This cancels. 3x equals 168. Divide by 3 on both sides. And we're going to get a value for x after we use the calculator. Clear that out, just make it a little bit easier. 168 divided by 3, 56. So we have 56 degrees, but none of these angles are equal to 56. All right, so we're going to put 56 here plus 17. And let's see what that equals to. 56 plus 17. 73. So angle 1 is 73 degrees. Then we're going to have 2 times 56 minus 5. And we're going to put that into the calculator. 2 times 56 minus 5. 107. If you wanted to check, you just add these two together. It would be equal to 180 degrees. It should be equal to 180 degrees. It's a straight line. That's how you know you're correct. All right, remember, you would never set these equal to each other. Like a person that did this, that person is saying this is wrong. That person is saying that these angles are equal. There's no way that this angle is acute and this angle is obtuse, greater than 90, and they'll be equal to each other. So you can't put down that angles are equal to each other unless they are definitely exactly the same. All right, and that's it. All right, so this question right here is a little bit more, asks you for a little bit more, actually all of the angles. So let's go ahead and see if we can do that. So the first thing that I want you to understand and I want you to do is to actually, when they give you what angle 1 is equal to, I want you to put it directly into the diagram. So this is 3x plus 27. And number 5, angle 5 is 2x plus 40. All right. So you have to decide whether or not you feel that these angles are equal to each other, they're congruent, or do you think that they are supplementary and they're different, they're equal to 180? Go ahead, try the problem, set up the equation, press play, see that you have the right equation, then press pause again and start to solve that problem. Press pause and try the problem now. Okay, so if you answered A as that they were congruent, that means you think that they're equal to each other, which is correct. They are corresponding angles. They're in the same location. This one is in the upper left. This one is in the upper left, right? Even if you didn't know that they're corresponding, you have to say to yourself, okay, that angle's acute. This one, angle 1, is acute, and angle 5 is also acute. They are the same. That means they're equal to each other. And that's why I set up the equation equal to each other, both of them. So now you would just have to solve it. So if you want to press pause again, go ahead and press pause again and solve the equation. I'm going to go and do it now. Hopefully you're correct when we come back. All right, so when we go ahead and solve the equation, the first step that we always tell you to do is get those x's together. I always like working in the positive, so I bring the smaller x over to the larger x, and 3x minus 2x is x, and you have 27 coming down, and you have 40. You minus 27 on both sides, and you have x equals 13. None of these angles are equal to 13. None of them. But now we're going to find measure of angle 1. Angle 1 is 3x plus 27. So I'm going to put 3 times 13 plus 27. And I'm going to do 3 times 13 plus 27. 66 degrees, so this angle right here, angle 1, is 66 degrees, and I'm going to put that directly in here as angle 1. Angle 4 and angle 1 are vertical angles. Vertical angles are equal, so that means they're congruent, equals 66 degrees. I'm going to go over here, put 66 degrees in for angle 4. What's the relationship between 4 and 5? They're across from each other on the inside. They are alternate interior angles. They are equal to each other. This one is 66 degrees as well. So angle 5 is 66 degrees. You could also substitute. You'll come up with 66. It would be 2 times 13 plus 40. So that'd be 26 plus 40 is 66. So that works out. There's one more angle that is equal to 66 degrees, and that is angle 8. It's the last vertical angle. There, 8 and 5 are vertical, and I'm going to put that down here. So now I am going to try to get angle 2, and by getting angle 2, I'll get all of the other measures. So I have 180, it's part of a straight line. These are supplementary angles. These are supplementary, minus 66. So 180 minus 66 is 114. 114 degrees is angle 2. 114 degrees, because they're vertical angles, 2 and 3. Now 114 degrees alternate interior, 3 and 6. And one more vertical angle here, and you are finished. Hopefully you were able to get that. That is, if you could do that, you could pretty much do any problem. So remember, it always is very, very important to start out with the right and correct equation. So if you don't have the right equation, you're not going to get the problem correct. So taking a look at this fast finisher, and we are going to do this quickly, I'm going to circle this and this. Do you think that they are equal to each other? You could use that crisscross method. Or do you think that they are different and that they are supplementary? If you said that they're equal to each other, you're correct. These are alternate exterior angles. And if they're alternate exterior angles, that means they are equal to each other. So we're going to set them equal to each other. We are going to solve, and I'm going to minus the 6x from both sides. Working in the negative, which I don't like to do, but the x is on this side alone, so I want to get the x's together. So I have negative x equals negative 9. There's a negative 1 in the front there, so I'm going to divide that. You can't have a negative x, so I'm going to divide that by negative 1, and x equals 9. If x equals 9, solve for x, that's it. That's the end of the problem. All right, it just says solve for x and you're finished. All right, just make sure. The idea is that these are alternate exterior angles. They are equal to each other. You realize that they're equal to each other. You set them up equal to each other, and then you divide, and then you subtract and get the x's together. Even though you're bringing the larger over to the smaller, you have to get the x's together on one side. So that means you work in the negative and you have to work through it. All right, so here's the next problem right now. Go ahead, same thing. Are they congruent or supplementary? Set up your equation. Do you think that these angles are equal to each other? Do you think that when you add them together they're equal to 180? Try the problem, set up your equation, solve your equation, substitute to find all the angles, press pause, and try it now. Okay, so we have, hopefully you're able to do this. These are supplementary angles, and they are equal to 180 when you add them together. All right, so you took x plus 15 plus the 3x minus 35. That's what they gave us. And we set them equal to 180. We combine the like terms. The 3x and the x is 4x. The 15 minus 35 is negative 20. You set all of that equal to 180, so you bring down the equal sign, you bring down the 180, you add 20 on both sides. This cancels. You have 4x coming down, the equal sign comes down, and the 200 comes down. You divide by 4, and then you get x equals 50. X equals 50. You have to substitute in. So we're going to take the first expression that they give us, the x plus 15, and we add the 50 plus 15. We substitute that 50 in. That is 65 degrees. So the measure of angle 4 is 65 degrees. 1 and 4 are vertical, so that's 65. 1 is 65, and so these are alternate interior angles. So that's angle 5 and angle 4. They're alternate interior angles. And then here the 8 and 5 are vertical as well. So they're all equal to 65. Then we substitute into here. This is 115. 3 times 50 minus 35, 115 degrees. Filling in all the vertical angles, angle 7 and that angle are vertical, angle 3 and that angle are alternate interior, and then 2 and 3 are vertical as well. We have all of the answers right here, and that's basically it. Hopefully you're able to do that problem and understand it. All right, we are on to our exit slip right here, and it's just asking find the measure of angle 1. Go ahead, create your equation, and find the measure of angle 1. Do the fast finisher also. Find the measure of all 8 angles, because if you find one angle, the rest of them pretty easy. Go ahead, we'll come back with and review this problem. Press pause now. Alright, here we go. So they are equal to each other. They're alternate interior angles. This angle here and this angle here are equal to each other. They're the same, right? So let's go ahead and solve. We have variables on both sides. I always try to get the smaller variable over to the larger to work in the positive, and that's exactly what I'm doing here. You minus 3x on both sides, you get 2x minus 28 equals 12. You add 28 on both sides, trying to isolate that variable. This cancels. You get 2x equals 40. Divide by 2, divide by 2. X equals 20. So think about what that answer is. X equals 20. Do you see A? 20. They're trying to trick you. They want the measure of angle 1, which is this. That's not 20. To get, you could either substitute into 3x plus 12, or substitute into 5x minus 28. I'm going to just do 5x minus 28 because it doesn't really matter, because these are equal to each other. Number 1, angle 1 and angle 5, angle 6 are corresponding angles, so they'll be equal to each other. And then these angles are equal to each other because they're alternate interior. But if you get the measure of this angle right here, you will get the measure of angle 1 because, again, they are vertical angles. So let's go ahead and 5 times and substitute in 5 times 20 minus 28. 5 times 20 is 100. Minus 28 is 72. So this angle is 72 degrees. That means this angle is 72 degrees. So B is 72. Fast finisher, find all the measure of all the angles. Alternate interior, this is 72 as well. These are vertical, so this is 72. Angle 8. So you do 180 minus 72. Is 108. So that means that 180 minus 72 is 108. Let me squeeze a 0 in there. 108, 108. Vertical angles, alternate interior angles, vertical angles, and that's it. All right. Hopefully you understand this lesson and this problem. That's the exit slip. That was the exit slip. So here is a challenge question. And I want you to just take a look at what the state exam did about 3 or 4 years ago. They have a quilt pattern shown below. All horizontal lines are parallel. They have to tell you that. And it says find X. So I am going to start highlighting or just tracing the lines. Take a look at that. And this. And this. Look at that. Parallel lines with a transversal. What kind of equation would you set up? Are these equal to each other? Is this equal to this little small angle? Right? Or do you think that they're supplementary? So I'm pausing because I want you to put your answer down if you think that they are congruent or supplementary. So hopefully you did get your answer. They are supplementary angles. They are not the same. They're part of a straight line. Supplementary angles equal 180 degrees. So if they're equal to 180 degrees, you cannot put an equation down that is equal to 180 degrees, right? These are going, so if they're equal to 180 degrees, you cannot put down that they're equal to each other, all right? So, sorry, I just made a mistake there. These angles right here are different angles, different measurements. So that means you're not setting them up equal like this. 4x minus 50 equals x. That is not the way you're going to do this problem. The question is saying, are these supplementary or are they congruent? You already said they're not congruent, so they are supplementary and they are equal to 180 degrees. So we are going to add them up and set them equal to 180. So once you have that down, you can press pause and solve the problem now. You remember, you only have to solve for x. Press pause and try the problem now. Okay, so now we are combining like terms. We have like terms on this side, one side of that equal sign. We have 4x plus x is 5x minus 50 equals 180. And obviously you're going to add 50 on both sides. And this cancels. 5x equals 180 plus 50 is 230. Divide by 5 on both sides, and then just to make sure, we're going to bring up that calculator. 230 divided by 5, 46. You have answered the problem. That's all they wanted. They didn't want an angle measurement, even though you could get angle measurements if you substitute this in. And actually 46 degrees, this is actually 46 degrees. But you don't need to do that because they're not. It says based on your answer from part A, set up and solve an equation that would help you solve for the x value. That's what you would do. All right, and that is that. Okay, so this is a super fast finisher ghost pepper challenge question, right? So there are 22 angle measurements that you have to find. They only give you that line J, this is line J right here, is parallel to line K, right? And line N is parallel, this line is parallel to line AB, line segment AB. This is a segment because it ends and ends, right? No arrows. Line segment BC is perpendicular to line K. Do you remember what perpendicular means? Perpendicular line forms what type of angle? If you said 90-degree angles, you are correct. They form 90-degree angles. And best yet, like, we're just going to go ahead and fill in before we even look at number 4, like 4, what they gave us at 4 and 5. We're just going to fill in all of the 90-degree measurements with this perpendicular line right here. And I'm just going to draw a line down for this perpendicular part right here that they're talking about that forms right angles left and right. Let's talk about 90 degrees. 16. All right, so 16 is 90, and I like to put them in as soon as I find them. 18 is 90. Perpendicular lines form right angles. If it's 90 on one side, it's 90 on the other. That's a straight line, 180 degrees. So that is, what angle is that? 18. 90 degrees. 19 and 20. 90 degrees each. 19, 20, 21, and 22, 90 degrees each. All right, do we have any other 90-degree angles? No, we don't. We don't. Okay, so let's talk about what's going on here. 2x plus 40 is here. So I'm just going to squeeze that above, and I know that 2x plus 40 is angle 1. And then angle 2 is 3x minus 70. So if I use these, like this 1 and 2, they give you 1 and 2. Are those angles equal to each other, or are they supplementary? Are they equal to each other, or are they supplementary? If you said they're supplementary, that is correct. Remember, this is part of a straight line. This angle 1 plus angle 2 equals 180 degrees. So I'm just going to write up here 2x plus 40 plus 3x minus 70 equals 180. Just going to erase those for now because I need the space. Alright, so I combine like terms. So I have the 2x and the 3x. So that's 5x. The 40 minus 70 is minus 30. So I have to solve this equation. I add 30 on both sides. If you want to pause and see if you could finish this problem on your own, finish all of those, it's a really good challenge. You could press pause now, or you could follow along. All right, normally in class you would try this on your own. You'd work together with this one, but we're not in class. So this is 210, 180 plus 30. So you divide by 5, and just in case, we are going to bring up the calculator. 210 divided by 5 is 42. Okay, so we're going to just go back to the full screen. That is 42, but there's nothing to put 42 into. But now we are going to substitute into angle 1. So it's going to be 2 times 42 plus 40. 2 times 42 plus 40. 2 times 42 plus 40. 124. Angle 1 is 124 degrees. And we're going to do 3 times 42 plus 40. 3 times 42 So I just want to say that I did make a mistake right here. See how I copied that incorrectly? That happens in a lot of times. That happens to me. It happens to a lot of people. 3 times 42 is correct, but it's not plus 40. And I realized it once this is 124. This cannot be above, like if whatever 2 is, if you add it to 124, it should not be greater than 180, because remember, we're talking about a line here. So, bringing up the calculator, 3 times 42 minus 70 is 56. So, 56 is angle 2. You can add them together, and you will get 180 degrees. So, angle 1 is 124. Angle 2 is 56. Now the easy part. Angle 4 is vertical to angle 1, so that's 124 degrees. Angle 2 and 3 are vertical, So that's 56 degrees. So 56. Take a look. You have parallel lines and cut by a transversal. So 3 and 6, what's the relationship between 3 and 6? If you said alternate interior angles, you're correct. So that if they're alternate interior angles, this has to be 56 degrees. So angle 6 is also 56 degrees. Angle 4 and angle 5 are also alternate interior angles, so that means angle 5 has to be equal to 124 degrees, so I'm going to put that down as well. Now a little bit of the vertical angles. So we have 6 and 7 being vertical, that is 56 degrees, so 7 is 56 degrees, and then 8 and 5 right here, 124. They're vertical as well. So now I'm kind of finished on this side, and I'm kind of hit a roadblock, but you didn't, because see this right here? If I extend it and then kind of like tilt your head this way, you see that there are parallel lines. You see that there are parallel lines here. And inside the parallel lines, right across from each other, are alternate interior angles. Alternate interior. So 4 and 9 are alternate interior angles. So 9 has to be 124 as well. And tilting your head again, what's 2 and 11? Alternate interior angles. If you look this way, here's the parallel lines, here are the parallel lines, it is 56 degrees. So 11 is 56. And if you take a look here, parallel lines again, alternate interior, 124. 13 is 124. And 56, and this one, they wouldn't even, they didn't ask you for it. I extended that line, but that would be 56 as well. But we're going to leave it blank because it's not necessary. So now we're going to just do some vertical angles here. 11 and 10 are vertical angles. You see across from each other like that, 56 degrees. Angle 10 is 56 degrees. Angle 9 and angle 12 are also vertical angles. This is 124 degrees. Angle 12 is 124 degrees. We're almost finished. So, little bit of confusion here. Do you see this right here? It's a triangle. So if you add 90 plus 56 and subtract from 180, you would get 15. So that's what we're going to do. 90 plus 56 is 146. 180 minus 146. 180 minus 146 is 34 degrees, and that means angle 15 is 34 degrees. Angle 15, 34. Well, since we have that, now we have 34 and 90, and we can get that last angle, that 14, by adding up 90 plus 34 is 124. And then we could do 180 minus 124. And that is 56. And so that means this is 56 degrees. You see, actually, you could have seen, let me just put that down, 14 is 56. There is no angle 17. So don't bother looking for it. Could have been this one. How about that? All right. If this was angle 17, it would be 56 degrees. Yeah. 11 and 14 are alternate interior angles. There are the parallel lines. So you didn't really need to do the triangle. It's just one way that you could. All right. And again, angle 10 and 14, there's a million ways that you could do this. Angle 10 and 14 are corresponding. So, I mean, like, you could have used that too. So all of that is done, and we are finished with this lesson. Thank you for watching. Hopefully you did well. See you next time.